Hi everyone. In this article we're going to be discussing launch control and drag style anti-lag. Often this is called two-step by a lot of people following the tradition of incorrect and non-specific names for car functions like dynamic compression ratio and trailing throttle response. But because two-step's often used to describe both of these functions, we'll describe both functions together in this article, even though they have two separate functions. Now, the first function is to control the launch RPM. Now this is because on most cars the ideal amount of wheel slip is a finite number. It's not zero, it might be 20% or something like that. And if you launch at an RPM that's too high, then you can have too much wheel spin and you don't get to put the power to the ground. If you launch an RPM that's too low, the engine can fall out of its torque band and you don't get to accelerate very fast. And the second function is to build boost. So with a turbocharged engine, you need to be able to have the engine producing boost when you launch, otherwise you're leaving power on the table. And to do that, you need to be able to do ignition retard to increase the GT and to spool up the turbocharger therefore. You can also do ignition cut, which allows the charge to combust in the exhaust before the turbine, which increases the exhaust pressure further, which helps build boost. And that reduces the life of the turbocharger and the engine, but if you're serious, that's what you need to do. Now to use this function, you'll need to have a vehicle speed sensor hooked up to the ECU, so that the ECU knows when to start applying the function and when it's out of the hole so it can stop and revert to the full power potential. Now to enable this, you need to go to the functions, launch control / anti-lag, and then go into the main screen of that and then select enable. And that will allow you to see the settings and enable the function. Now assuming that you want to build boost, then you'll need to select ignition cut as the method. The only reason I can see for using fuel cut is if you're using a naturally aspirated engine or something like that, which doesn't mind having its fuel cut as a rev control mechanism and where you're not trying to build boost at the same time. In general, we would recommend using ignition cut. Now the next selection is the speed selection. So on an installation with just a single road speed sensor, for example off the back of the gearbox, then you'll have to select driven speed. And this is how the ECU determines what the RPM limit should be. Ideally, you'd actually take this from the ground speed, but to do that you'd need 4 wheel speed sensors so that you could take the speed from the undriven wheels to know actually what speed the car's doing. It should be fairly obvious that once the clutch is fully engaged, the RPM and the wheel speed are closely linked anyway. So being able to do a rev limit based on speed doesn't really make much sense. As an example, if you've increased the RPM limit at the higher road speed, then if you launch it too high in RPM, then the road speed's going to be high because you're wheel spinning too much. So that won't actually help you in that condition. Now the maximum speed is the next setting, and that's the road speed above which the launch control and anti-lag function won't operate at all. Now the next setting is the RPM versus road speed table. So this is the table where you select the RPM limit at each road speed that you're allowed. Now if this were a strict two-step system, then the RPM limit would be fixed as a function of road speed, and then above the maximum road speed that you set earlier, it would be disabled altogether. So you'd have 2 separate rev limits there, which is where the term two-step comes from. But with this system you can gradually ramp the RPM as you need to. Now the next setting is enable drag style anti-lag, which if you're trying to build boost on the launch, then that's what you need to enable. So the next setting then is the RPM window. This is the range of RPM over which the ignition retard and fuel enrichment is brought in, and it's also the RPM range over which the ignition cut or fuel cut is phased in as well. So for example, if you set the RPM limit to 5,000 RPM and your RPM window is say 500 RPM, then at 4,500 is where it's going to start to phase in the ignition retard and fuel enrichment. By 5,000 RPM that'll be all in, and then from 5,000 to 5,500 is the range over which the ignition cut goes from 0 to 100%. So for example, if we set our ignition retard to 40 degrees and our fuel enrichment to 10%, in the earlier example rev limit is 5,000 RPM and our RPM window is 500, then at 4,500 RPM and below the fuel and ignition time is just going to be unmodified. At 5,000 RPM you'll have 40 degrees of retard off the mat and 10% extra fuel, but no ignition cut. And then at 5250 RPM you'd have the full amount of ignition retard and fuel enrichment, but 50% ignition cut. And then at 5500 you'd have 100% ignition cut. So just like all the other functions, you can see all those variables and the amount of fuel and ignition cut that you have because of the launch control, and the amount of ignition retard and fuel enrichment that you have from the anti-lag. You can see them all live as it's happening. Also whether the conditions for launch control are met, and these are all saved in the log file as well. Now one last thing I sort of mentioned earlier, doing ignition cut on launch like this does reduce the life of a turbo. For quite a while I was running one of my street cars by just doing retard and enrichment, and it ran for several years like that with no problem. It doesn't make the bang 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 sound that everyone likes, but it certainly helped build boost off the line. When I started enabling the ignition cut, it was a lot more bang bang bangy, but it reduced the life of the turbo to a few months. Now, having said that, it probably wasn't the most durable turbo on the market, but all the same, just be aware it will reduce your turbocharger life. Thank you very much.